the base, right? So regular merge tool are based on text block level. It's like the merge tool we include with plasticscm. They are all based on just looking for changes in text. But what Semantic Merge is able to do is to actually handle the conflicts at a structure level. What does it mean? Well, we first parse the code, and we do create some sort of intermediate trees, right, which are the ones we later handle to deal with all the merging stuff. Then we calculate different diff pairs. Basically, we calculate the diffs between the source and the base, and the destination and the base. Okay, just to make it a little bit simpler, suppose base is how the file was, source is the change made by Violeta, and destination will be the change made by me, right? So that is what it is about. As you all know by now, three-way means it's able to actually know when something has been added or deleted because it will compare to how it was before. Well, so the merge algorithm, the semantic merge algorithm, will actually go through the two lists of differences, and we'll try to find conflict between them. So suppose you change a method in source and you also change a method on the destination, then of course you have a conflict. The beauty of the algorithm here is that it won't get fooled by methods being moved, right? So if you move a method up and someone else moves the same method down, it's not an issue, while it will be a nightmare for most of the text block-based tools out there. So our goal is actually to enable what we call string refactoring. Okay, string refactor is just something I made up for this presentation, right? But the goal is to actually let developers really do all the kind of changes they want and be able to merge them in an easy way later on. Okay, let's go next. So how do we think semantic merge can actually help in development? Well, the point is the following. We were always motivated by this graphic you have here on the right. You look at the graphic, this is basically the very famous evolution of the cost of making a change into a software project. Barry Boehm, back in 1981, said, well, the later you make the change on the life cycle, the much it's going to cost you, right? And this is basically like a rule of thumb we always follow for decades, right? But then later Ken Beck, one of the minds behind the agile movement, said, if you keep your code clean, if you refactor, if you actually invest on code quality, you'll be able to keep the cost of change quite low. Well, actually not quite low. Actually, it will grow. It will grow not as fast as it will do if you don't do it, right? So basically, these are the two curves that normally motivate us in all these things, right? So the point here is, well, what do you need to keep your code clean? Well, it's probably not just a single answer, right? But one of the things you need is to make a lot of changes, keep it clean, rearrange the code, refactor it. When you do that, you normally have to somehow lock the file, do the cleaning, then someone else can modify it. But all the goal behind semantic merge is to actually let you keep your code clean, because you can refactor without fear, let's say, because you know the tool is going to be able to merge it later on. So there are two things that are important for us. First, semantic merge helps you with the types of merge conflicts you have today. What does it mean? We have rerun a lot of repositories. We downloaded from the internet, our own repositories from customers. We rerun all the merges there, and we found out that about 15 to 20% of the merges can be actually simplified by semantic merge, right? Which is very cool. But there's something else. I mean, this is how it can help you with the practices you do today. But more importantly, it will enable, and that's the whole point with semantic merge, it will enable to do things differently. It will enable to clean up the code, to move methods, to split classes, and be able to merge them back. So that's a little bit of what it is. Well, feel free to ask questions. Violeta will help me dealing with the questions you may ask, right? And if someone wants to actually speak instead of just write, you just have to raise your hand with this virtual system, and we'll keep track of that, right? Okay, so let's continue. A little bit of history. Well, you may wonder how we end up doing this thing, right? Well, there's a funny story here. Well, programmers always ask us, does plasticscm merge tool understand the code? Because it seems obvious for most of the programmers, especially at the very beginning when we are not so used to deal with diff tools or merge tools and so on, right? You just think, okay, but if I change something, how is the tool going to understand? At the end of the day, a text block-based merge system, a text-based merge system is not about understanding, it's just about some logic on the text, right? Just, okay, if I modify line 1 and you modify line 10, most likely is that they are not going to collide. But the thing is that it's always something that is on the mind of developers. When we actually did the launch, like 2 weeks ago or so, a lot of people was saying on Twitter, look, this is something I thought it should exist already, but it didn't. So it's like a good idea. So the point is, we all had it in mind. It didn't exist, at least not in the way it does now with Semantic Merge. And then we start to say ourselves, right, why we didn't do it before? Because it's so, so obvious to come up with something like this. And the whole story is that it wasn't that simple, right? Well, first, the entire merge algorithm we use is not actually reused, but it's based on what we have on the merge machine. And you have the link here on the screen, merge machine in plasticscm.com, which actually explains all the types of merge conflicts that plasticscm can handle. Of course, dealing with branches and merges and directories and files. So basically, everything that this merge machine is able to do with files and directories is what we applied for inside the file, right? So everything that you can do with different files can now be done inside the file with methods and properties and so on. It all started back a few years ago also because we released something called Xdiff and Xmerge, or crossdiff if you prefer. It's up to you, right? Which is currently included in plasticscm and was somehow, well, it's also right now in Semantic Merge. It's actually a text-based merge tool and diff tool which is able to track moved pieces of text. It was like our first step towards what we have right now, Semantic Merge. So at the end of the day, the whole Semantic Merge is something that we had in mind for years actually, but we were, trying to develop and to have all the technology to actually make it happen. Well, as I said, Xmerge was our first step towards the semantic thing. You can check it on this site, and basically what you see on the screen is a little bit of what it can do. You move some code, as you can see here, and it's able on the diff tool, on text-based diff tool, is able to draw a line saying, look, this is the same thing that has been moved there. In fact, even if you modify it a little bit, in my case here, you probably cannot appreciate it, but there's a count equals to 1500 or 1400 that actually is different. So it's able to track the move even if it changed a little bit. In fact, it's not affected whether what you move is a full method, as I did here, or just a piece of text, or just a block of text, or just something between two methods, or whatever. It was our first step, but we thought we need to have something better. The good thing about Xmerge is that it's language agnostic, so you can use it with any language you want. But the next step was to actually make it language aware. And these are some of the key concepts we handled. First, we wanted something to merge on a method by method basis. Okay, when I say method by method, you can think of class by class, attribute by attribute, property by property, whatever, right? But the point is, what we normally focus on when we talk about this is our methods, right? So you move a couple of methods, you want it to be able to deal with it. So look at the example below. Actually, what we did there is, well, in the source, well, we have a class with a couple of methods, and then we just change, rearrange them, right? So method 2 is going to be the first now, method 1 is going to be the second. At the same time, someone else modifies, that's why I put it in red, method 1. So this very simple example is going to be problematic if you try it with a regular text-based merge tool, because what the merge tool is going to do is going to compare destination with source, and it's going to try to match method 1 with method 2, and it's going to be a nightmare, right? We tried to solve this with our Xmerge before, we can handle some situations, but as soon as the AI scenario gets really complicated, Xmerge cannot handle. That's why we came up with Semantic Merge. So with Semantic Merge, this situation is actually pretty simple, because it's going to be able to identify method 1 as the only one being modified, will run a three-way merge based just on the text of the method, and you'll be able to figure out what's going on and to solve it and so on. So this was the whole goal. Now, I like to cover a little bit, because some of you have been already playing a little bit with the tool and might be wondering, well, why it looks like as it does, right? Why it's the way it is. And that's why we feel we should explain a little bit why it looks like it actually does, right? So the first thing is, we couldn't actually try to make something as you can see here, right? This is the regular three-way merge tool layout. You have the base, the source, the destination. Some of the tools don't actually show the base, and then you have the result. All is based on the side-by-side diff analogy. So you put two files, one side-by-side to the other, and then you check what's being modified, and you handle that, right? The thing is that it doesn't really work for the type of problem we wanted to solve, because the main problem when you have a lot of changes, and changes can be really easy, like just moving a few methods up or down, right? This way of rendering stuff doesn't actually work, because you end up with methods being crossed. I mean, one goes up, the other one goes down, so it's very difficult to track what was modified. So that's why we wanted to come up with something different. Suppose you move a few methods around and then modify one of them, something like this, right? You have three methods, full bar and zoom, and you move them a little bit, and then it's like a nightmare to actually figure out what happened, right? So the main idea we had behind the GUI approach was to simplify and show only the relevant information. So if you move only one method and you rearrange the full file, the only information that is really relevant is that you move the method. Of course, you'll find out later that you also move the other stuff. But the really important thing is to find the conflict in case it happens, and try to find what the relevant things are. That's why, okay, let's go again for a case like this one screen, right? Exactly the one I showed before, like two methods moved, and then you have the result and so on. So if you move a couple of methods this way, all you will have with Semantic Merge is something like this. Take a look at the GUI. Take a look at the arrows too. You will get only one conflict, because look at the scenario. At the end of the day, yes, you move the method, but the really important thing is that you just modify same method twice. So what you see here on the screen is you just have one conflict, you can see there, and then we use some icons. And the icons, and that's very important to understand. You see C means change it, M means moved, we have D for deleted, and A for added, and that's the only 4 letters we use. Well, I think we also use R for rename, right? Which is special case of move. So the thing is, if you just take a look into the conflict, you see a C and a C. C on the left means change on source. So look in the source, method 1 was modified on source. C on the right means change on destination. So if you have C, it means you have a conflict. Also, you have extra information. It was moved on the source, and there's no movement of the destination, so that's not a conflict. That's what it means, right? This is actually the way in which we wanted, or we think, representing the information, rendering the information is useful for you, because we simplify a lot, right? And then, of course, you have the merge button to just solve this case. Well, you may wonder why we came up with all this. Well, as I said, we just have to focus on the icons, and at the simple, at the first glance, you'll find out what happened. And that was the main idea. The inspiration for that, well, actually, one of the inspirations for that was what you see now on the screen. We wanted to come up with something sort of sci-fi, something like coal with beautiful information on the screen and so on, but okay, there's actually another motivation behind, which is something that we are going to be working on soon, which is the following. Look at this example here. This is actually a draft of something we are working on, which is visual diff. Look at the three contributors. The base, the source changed by me, the destination changed by Violeta. And now, if you look into the center piece, you see, okay, the class socket was actually renamed to DNS. Okay, that's very simple to understand. The method listen was moved down to server socket, while the connect to was moved to client socket. Client socket was added because you see something on green there. Well, at the end of the day, when we draw that, when we came up with this idea, we end up drawing two icons, one on one side, the other one on the other side, representing what the operation was about. So what you have now on the screen on, Semantic Merge, something like this, is actually the first step towards having something like this. Our goal is to create some sort of visual diff based on all the engine, all the core we already have, and well, be able to show the differences this way too. But what we have now is let's say the fundamental idea behind, which is, okay, you have the conflict, you have the icons representing what it's all about. Okay, do you have any questions so far? We'll be more than happy to answer if you have any questions. Okay, let's go then. So let's now check a few examples. I'm going to actually try to run some examples using the actual tool and let you, well, see how it works, right? So suppose we have a class called Simple File System. In this Simple File System class, we have a few fields, and then we have 4 methods. Now suppose one of the contributors, what he's going to do is to actually move the right selector method down, so it's going to be the last one in the class, and also modify. That's why I put it on red here on the example, so it's very visible, right? And then what the other contributor is going to do is to move right selector to a different location and move the fields down, right? So it looks like not very complicated. At the end of the day, you just modify the same method, right? So it's not very difficult, but well, it will be a nightmare for a regular merge. So the source changes can be easily tracked by Xdiff, by something like Xdiff, as I told you before, right? Because, well, I have it on the screen right now. I have a screenshot here. You see the right selector method is moved down. So that's not very difficult to track even for a text-based tool. Of course, you can track it with semantic diff, which is actually part of Semantic Merge. And the way to show the information will be a little bit different, right? You see the method has been moved and the method has been changed. And that's all you see, right? The rest of the information is actually not relevant. In fact, I'm not showing you the entire class as you will have here, but just what was actually modified. For a simple case like this one, the text tool is good enough in order to actually understand what happened. And in fact, since we are more used to it, you can say, okay, I better understand the operation from here than from here. And this is one actually, that's actually one of our concerns and one of our ways of improvements. We have a lot to do with Semantic Merge today, right? So these are one of the things we want to improve. But still, when the operation is very complicated, it's very easy to check what happened here. Now, the change on destination are slightly more complex because, well, semantic diff will let you check actually what happened. Remember, I moved the right selector and I also moved the fields down. Actually, today, what it's finding is that it's finding the method has moved up, which is actually equivalent. Let me remind you that I moved this right selector down, which is equivalent to say selector fs open directories and right select, well, moved up because the fields also moved down, right? So it's a little bit of what it happened. Let me go to the tool. I actually ran this example through plasticscm. Some of you won't be familiar at all with it. I just focus on the part of the merge, right? So what I'm going to do is, well, this is a source contributor. I can diff it. I can show you that only a single file was modified. This file, you can see the diff here. This is actually Xdiff in action. I can also type Control D and show my diff tool. In my case, the semantic diff, and as you can see here, I can check what happened, and I can also run the diff for the method. In my case, I have configured kdiff3 here as let's say text-based diff tool, so you can see that we can also integrate with other tools and so on, which is kind of cool, right? So you see that I not only moved the method, but I also modified it. And actually, I changed this 0 by a 10, right? Okay, that's all. So let's now take a look at the other contributor. So let's go back to Plastic, and let's take a look at this one. So if I diff this one, I will also see the file system file modified. This time, the operation is a little bit more complex, as I told you before, because I moved all this block down, all the attributes from the very beginning to the bottom of the class, and I also modify right selector. This time, what I did, well, this text-based tool is also included with Semantic Merge, so you can also use it. I can run a subdiff, and in the subdiff, you see I actually added like a diff here, right? And that's all. Of course, I can go and diff it with Semantic Merge. In this case, it's going to be also simple to understand what happened. You see the right selector was moved, and then you also see all the other stuff, right? Like all the other methods moved and so on. Okay, once we have that, the next step would be merging. In order to merge, well, I will use Plastic here, but of course you could be using Subversion, Git, TFS, Perforce, anything you want to use, right? Because we actually, our goal with Semantic Merge is to make it usable from any version control system, so it's up to you. So I will run the merge. I will present it. Okay, this is of course how Plastic handles it. It will be completely different on your SCM. Of course, we recommend you to use Plastic, but that's another story. And then once we launch it, we're going to see the Semantic Merge in action. Okay, remember the case. Let me just go back to the diagram, right? Just go back to the diagram here. So this is the case. You moved one method down, you move the other method to the same method to another location destination, then you move the fields. And let me show you what plasticscm is doing. It's saying, okay, the method right selector was change it and change it, so you have a conflict. But it was also moved and moved. And it's telling me, look, you move it down 3 positions on source, but you move it up 7 positions on destination. So it's telling, well, I can solve that automatically. Why we do that? Well, in order to simplify things. By default, it will keep, when it's moved inside the same scope, which means you move the same method and 2 contributors, but inside the same class, not moving to another class, it will, by default, get one of the moves, because it's very easy to later on go to rearrange and just move it back again, right? Or put it in whatever location you want. So there's only one conflict left, which is the change you made both on source and destination to the same method. From here, you can go and diff it. Right now I'm using our built-in diff tool, right? So you see I modify 0 by 10 on one contributor. I can go and diff the other one. Okay, I can go and diff the other contributor. Now you see I added the if, right? So that's the other change. And of course, I can go and merge. What's the great advantage for me here? Well, it's very common on big development teams, especially, that you end up doing something like this, right? Probably not as forced as this example I have here, because it's just, it's just like 4 methods on a class, very simple change, and forcing to actually make it simpler, right? But it can actually happen in real life. And the thing is that here, when you click on merge, you won't be actually merging the whole file, but just the method. So it's what we call a submerge. It will be able to just merge the ancestor of the method and the 2 contributors of the methods. Remember, they are in completely different locations on the 3 contributors. So on the base, it was in one place. On the source, it's in another place. And on the destination, it's another place. So I can just go through it and find the solution. I can just, double check whether the solution is fine, pick another one, whatever. Once it's done, you can even go and just view it on result. From here, you can go and rearrange. You can, of course, inspect what was modified on source, on destination. In fact, as you can see, the diff tool is just a subset of the entire merge tool, right? So you can see all that. You can see how it's now there on this location. You can go and move it if you want. You can just go here and right selector and drag it like this, and then you change it to another location, all this stuff, right? Let me just, for 1 second, you see there are more buttons here. Let me just run the merge tool. Why would you like to do that? You can run the merge tool if, for instance, you cannot run, suppose you are dealing with a class that is not correctly parsed for some reason. Well, normally Semantic Merge will just tell you, well, there are parsing issues, so you are free to just go and run your conventional merge tool. But you can also go here to compare and check what is the result. And look, we only had one conflict on a method. Compare that to this situation. It's finding 4 changes. It's finding only one pending non-automatic, which is kind of cool. But the problem is that it doesn't make a lot of sense, right? It's trying to match the privates with the right selector here. I mean, the fields with the right selector. It doesn't make any sense. So we go from super easy to nightmare in a second. And this is, of course, not one of the worst merge cases you come up with, right? So I won't save, so I keep this other result. And, well, that's a little bit about how we can handle one of these merge conflicts, right? Which, well, we are so excited about this because we think, well, we started with C#. We are about to launch Visual Basic very soon. In fact, Violeta is running the latest tests right now. We test with like 2 million files of every language. Visual Basic a little bit less because we actually didn't find so many files on the internet, right? That's a reason. We tested with C# with 2 million files, just parsing them and rebuilding, and also running a lot of merge replay, which is basically downloading a repository from the internet and replaying all the merge situations and checking they are okay, right? We did that with C#, with Visual Basic, with Java. Java is almost ready to be out, but we are just trying to polish the last details. And well, that's a little bit about it. Right? So we'll exit without saving and jump to the next slides, right? So, okay, well, this is the merge. As you can see now on screen, basically what I already showed you live, right? Well, we added a few buttons that some people were asking about. Well, since this is still beta, maybe we keep it. Okay, we have a question from someone, so let's check. Yeah, okay, David Lay is asking for JavaScript, CSS, and HTML. Okay, JavaScript is actually like the number 3 on the list of top requests from users. We will definitely have it, right? We will definitely have it. CSS and HTML, well, both for them. I mean, we will probably react on that. I will also share with you later on that we are going to open up the platform. So let me just continue. And, well, if you have any other questions, I'll of course, be happy to answer. Let me continue because I'll be talking about the future languages in a few minutes. So, as I said, only one merge conflict. The text-based merge will run at the method level, which greatly simplify things, and the location of the right selector move divergently inside the same scope is actually not an issue, right? So, another case, and this is one of my really favorite ones, the splitting the socket class. If you went through the information we sent for the people who joined the evaluation phase, or if you go to the intro guide we have on the website, you will see this case, because this is actually one of the scenarios who inspired all of us to come up with and to develop Semantic Merge. So here's the situation. You have socket class with a few methods there, and then one of you goes and creates server socket class and move a couple of methods there, like listen and recb, which look like belonging to the server. And then someone else, and you also go and rename DNS. That's a little bit of a trick that you will see at the end, but let's continue with that. And then on the other side, you have socket class there. You move a couple of methods down to the new client socket class. Now here in this example, I'm using the colors that we use on the GUI, right? Green for new, blue for change it, and whatever this color is, purple. Violeta is telling me it's purple. Okay, this purple color for moved and removed, right? So let me just jump to the tool and show you this case. I'm sure you are all pretty aware of this scenario, But well, if you go to the installation of the Semantic Merge, we have a samples directory. Well, some of the people was asking why we install under app data local. There's one reason for that, is that we implemented an auto upgrade mechanism, auto update mechanism for the tool, so you'll be getting the new releases just automatically when you start up, and it's much easier to implement if you have in your local directory, because then there are no permissions issues and so on. If you still want to keep it, on your program files, that's fine too, but then you'll have to like download the new installer and run. That's all, right? So under the Semantic Merge directory, as you know, you have a few examples, and actually the socket one is the scenario I was describing here on the slideshow, right? So we have the socket class, and then we will split it into different classes. This scenario is worse than an Xmerge with a regular merge tool. Let me just run it with a conventional merge tool, actually, or Xmerge, which is pretty good, but not good enough for this. Look, 3 conflicts not able to be solved automatically, like new different changes, and you can go through them, but the problem is that, for instance, here, you are trying to reconcile recv with get host by name, which actually don't match, so it's a little bit of a nightmare, right? You see that get host by name was modified here. It said when you give an IP, now it says when you give an address, but it's trying to match it with recv, which doesn't make any sense. It's actually a very good example of what the tool, what Semantic Merge should do. So I will just close it and run the sample Semantic Merge tool. We actually created all these bat files to help you running the examples and getting a little bit familiar with what the tool can do, right? So if I launch Semantic, you'll see first there are no conflicts to check. This is actually the philosophy we wanted to have for the tool. So it just lets you focus on what is important, what is relevant. So what is relevant here? There are no conflicts. So nothing to do. You could just go, save and exit, and you're done. You can go, check the result file, and you see it actually matches the result you expect, right? So you have the new methods and server socket, you have client socket with only the 2 methods that were left, and the old DNS class, which was, it was socket and was renamed to DNS, will just contain the get host by name class. This is a little bit of a made up example because I didn't even put code inside the methods, right? But it actually represents very clearly what happened. So I can go to changes and see all the changes for the 2 contributors together. I can go to source or destination, or I could even go and rearrange the file. That's actually part of the beauty of the tool, right? Just let you focus on what is important. I think there are some questions coming. Okay, Violetta is telling me. Okay, so Placido is asking us, suppose one file as base and the 2 contributors are other 2 methods with the same name in same position, but with 2 slightly different implementation. May I handle this case using the all 3-way merge? Okay, that's a very good question. In fact, I think we covered this one on the website, but maybe not explicitly. So the point is the following. Suppose you added the same method on 2 locations. For Semantic Merge, it doesn't really matter whether the methods are added on the same location or not. For a regular merge tool, it will, but for Semantic, it doesn't really matter. It will understand it's the same method, and since they are both added, you will have the option to 2-way merge them. Why I say 2-way merge them? Because you cannot 3-way merge them because there's no base, because they were not there before. In order to do the 2-way merge, you need to set up a 2-way merge tool, which is one of the patterns you can send to Semantic Merge. We normally use KDiff3 for it because we didn't have 2-way merge support to our own Xmerge tool, which is something that is like on a pending list, very big on the pending list, but never done. So yes, you can handle this situation, Placido. Okay, so we went through another example, and now I'd like to just go back to the slideshow, if I find it, here it is, and jump into the next step. So what's next for Semantic Merge? Well, first thing is we're going to release Visual Basic.NET support really soon. Violeta was just receiving a message saying we are almost ready to get it because it passes actually the last test. It's almost in 0%. 0%. Okay, cool. So no known issues in parsing and rebuilding. Next, we're going to release the Java support. Actually, we focus first on C# and Java. Well, Visual Basic was very easy to come up with together with C#, but C# and Java, because with only these two, we're able to cover the largest majority of development community out there, right? Because you really have, according to some of the reports on languages, you really have a huge number of developers on just these two languages alone. So next, we have to decide, well, C, C++, actually not the same thing because C is much, much easier than C++. We will probably have C earlier than C++. We are already working on that. In fact, the team started working on that back on February, even a little bit earlier, working with the leaf CLang, the CLang libraries, Clang. So these are basically the technology we are going to be using. Next, we have some big requirements for other platforms like Mac OS, like Linux, GUI, and so on. We'd like to add the graphical merging and diffing features I showed you before. I think this is going to be great because it really will simplify, because, you know, right now what we have here to actually show you the differences, it's not bad, but it's not perfect either, because it's good for added or move it, or sorry, added or change it, but for move it, it's not that simple to understand, right, what actually happened. Because yes, you find here, well, it was moved to network socket from network client socket, but it's not as simple as, you know, just seeing a line going from the source to the destination. So this is one of the things we're going to be working on. Then we have to deal with a lot of improvements like usability. We'd like to improve a lot the rearrange view, because, well, it's doing its job, but it's far from being perfect, right? So we need to come up with something better here, something a little bit more usable. It has some issues also. More cases, like for instance, the tool is getting a little bit full. It doesn't mean it fails, right? But it's showing like moved and modified when it should only say moved when you have issues with blanks. Like you move a method, then it gets a little bit full with blanks on top and something like that. It won't fail. It's perfectly usable in production, that part. But it's something that it's well, it's very possible to improve it, right? We also need a better text editor, probably with indentation options and stuff, and reformatting and things like that. And well, these are some of the really basic stuff. Now, the next one is going to be the really super big feature, which is, what if you split the socket class as I did here, right? As I did here. What if I split it, but instead of just going into different classes on the same file, what if they go to different files? That's something that we already started, actually not implemented, but researching. We have a couple of very good solutions for that, and we'll be adding that. And then it's like closing the circle, because then it's going to be a really super big, because this really means refactor freedom, right? Then there's something big we're going to announce today, which is, well, today to you guys attending the webinar, which is we're going to let users add their own languages. In fact, we're going to release in the coming weeks some sort of dev kit, so you're able to just generate your own intermediate tree that we need for parsing, and then any language that you want to put there, even if they are, for instance, the gaming industry is very common to have people developing their own scripting languages and so on. You'll be able to come up with it and add semantic merge support. So it's going to be very easy, because it's about generating the intermediate tree, which is basically a tree saying where each method or class or whatever element is on the language. And what we're going to release also, the tools we use to test. So suppose you add your own implementation for Scala, right? So we'll give you a tool so that you give it a big directory tree with, I don't know, 2,000, 3,000, 20,000 Scala files. And then first thing is you're able to parse it and rebuild the file. So we'll give you the test tree to actually test it. You'll have to, of course, fill in your own language. Of course, we'll be working on adding more and more languages. JavaScript is one of the ones we want to have very, very quickly. also C++, as I said, Java, of course, right? But opening up, we will actually turn Semantic Merge more into a platform than just a tool, and I think it can be a very good idea. So user feedback, we're also reacting on user feedback. We have this user voice forum where we are getting a lot of votes. It looks like a race because the Linux and Mac OS users are like voting on a daily basis. Now Mac OS is first again, but it's 251 votes together with Linux. Linux was first this morning, so it's kind of constantly changing. Next one is JavaScript. So for David Lay asking before when JavaScript is going to be there, well, it's number 2 after the 2 platforms, right? So it's very important. C++ is like the racing star, is getting bigger and bigger. Then we also have some questions for things like CML files. There are good tools out there like Altova, right? Altova has very good tools for different emerging CMLs, but I think if we add the semantic support, it can be great. That's something that we've been discussing internally, how we can do that. We've been asked that several times by several people since we started talking about semantics, so something we have to figure out a little bit. I don't have yet a clear idea of how to handle it. I think parsing it is not going to be hard because there are like tons of libraries to come up with it. And then the merging shouldn't be an issue too, provided we put some restrictions like, as soon as it has the same name, the same element and stuff like that. The good thing is that it can help us with project files from Visual Studio and all that, right? And probably CML files too for Windows Presentation Foundation and all that. Then there was a lot of votes there saying something like amazing Visual Studio support, and we will need a little bit of more feedback here because I think the people asking that wants the tool to run within Visual Studio, which is pretty doable. But well, we don't know if it really adds that much value compared to just running an external tool. We have to talk to the people asking that. So if any of you guys are want this feature, please let us know once just raise your hand and let us know a little bit more about it, or just type about it. And then more languages like Python, C, Ruby, Objective-C. Actually, Objective-C is inside the same initiative with C and C++ because we will be most likely using Clang to actually parse it, which is going to be like the same thing. And then Scala, F#, PHP, Delphi. I love to add Delphi because it used to be and still is one of my favorite languages, right? Object-oriented Pascal, which is a very, very good one. So I love to have support for it. And as I said, our plan is to open up the intermediate tree, so more languages can be added by contributors, and you guys can all just download the application to generate the tree and use it within Semantic Merge. So this is a little bit of what we are doing based on our internal ideas, the user feedback, and so on. And now it's your turn for questions, right? We love if you guys can follow us on both Semantic Merge and plasticscm on Twitter. But well, now it's the turn for questions. So any questions you might have, we can spend some minutes trying to answer. Up to you guys. It's your turn. We'll be actually uploading publishing, getting this webinar published on YouTube, right? So if you want to share it with your friends and just try to watch it again or something, it will be ready there. Any questions so far? Okay, we don't see any questions, so please guys don't be shy. Okay. Okay, so we get questions about what is the performance when the merge files are huge. So maybe Violeta can let us know a little bit about it. I'll just unmute Violeta. Please mute me first, Vio, otherwise it's going to collide.
Muted.
Hello, now I think you can hear me. Okay, answering the question of Placido, I can say that the performance is really good. We have tested a lot of files and really huge files, and it's about seconds. So there is no problem for us, the performance. at least until now.
So,
Unmuted.
so Bio, can you tell us what's the size of the files you actually merged? Do you remember that? How big they were? How many?
The minimum of lines?
Yeah, how many lines of code or something like that on the biggest file?
I can't say the number of lines, but really far.
Muted.
It's maybe thousands of lines.
How many? Thousands. Thousands not that big.
Oh my god.
Something like 10,000, 20,000, something like that?
Maybe like 10,000 of lines.
Unmuted.
Okay. There's another question now from Andrew. Okay, the pricing structure. Well, we're still not completely sure about it. The goal we have is to make it really affordable, something like in the around 30, 40, maximum $50 per copy or something like that. No more than that. That's the goal. But we're still not. I mean, it's still not closed, right? We're still trying to figure out what the model is going to be. Placido was asking also if maybe 10K lines. I mean, like 10,000 lines. I think we tested with something different. But what we're going to do is to check back the test because it's currently running on an automated mode, and we'll post the result on Twitter, right? So you'll be able to see it. Okay, more questions? Okay, so if there are no other questions, okay, there's another question coming. So I'll read it. How does it handle scenarios when code is moved between files, or a file is split into two files, or two files are merged into one? Something that Git merge algorithms handle to an extent. Okay, that's an interesting question. Well, first, we still don't have the support to handle moves across files. It's something that we will be adding soon, as I mentioned, like when covering the roadmap and so on. What you mentioned about that Git can handle to some extent, you can do like the git log -c if I remember correctly, and then you can annotate the file, even figuring out where the lines went. But I'm not completely sure whether they have merge support for that, right? Anyway, you could use Semantic with Git too, right? So that wouldn't be an issue. Actually, the main issue we have with that, as far as we know so far, is the following. In order to do the inter-file semantic merge, we will need the version control system to send out the list of all the files involved into the merge at once. So normally how merge tools are invoked is for every conflicting file you get invoked once. What we will need is to change that and be invoked with a list of files, because we will actually have to parse them all and find the movements between the files that were sent for the merge, right? So it's not very difficult. It will be something relatively easy to implement. It will be trivial to implement within plasticscm because basically we can control how the merge is invoked. But for Subversion, Git, Mercurial, Perforce, and all of them, we will depend a little bit on how they will invoke the tool and so on. Okay, more questions? Well, it's not your turn, so don't be shy. If you have questions, please ask. Okay, another one coming. Okay, so Mikhail is asking about the art in Semantic Merge website. Well, actually, we have a pretty cool web developer and designer who joined the team like 3-4 months ago, and you know what? Everything has been changed since then because he has so many cool ideas, and he's able to implement all these beautiful graphics and so on. So everything looks like much better than it did before. Actually, the idea behind Semantic Merge, well, we wanted to do something like the machine can communicate with you and understand what you're trying to do. So the entire idea is about understanding your code. And in order to understand your code, it's like, well, like a machine can understand your mind, can read your mind, which is, of course, not exactly what we do so far. But you know, that was the whole idea. And then, you know, like this big alien robot communicating to the guy and all these sort of sci-fi drawings you see on the screen. Okay. Okay. Okay, thank you guys. So thank you everyone. If there are no more questions, we'll be finishing for today. Of course, feel free to reach us on Twitter, on support, on we'll be opening a forum for questions and answers real soon. So feel free to send us as many questions as you have, right? So thank you very much. Thank you everyone. And okay, see you next time.
Thank you everyone.